Good morning, sir. I am Pushparaj, HOD Mechanical. I am happy to introduce Dr. M. Varadaraju, Postal Doctor Fellow, NIT Trichy. He has completed his UG Production Engineering in Adiyaman College of Engineering in the year 2006. He has completed his MBA Financial Management in Annamalai University in the year 2009. He did his PG MTech CAD at Pondicherry University in the year 2012. He got his doctorate from Research Center, Saranathan College of Engineering, Anna University in the year 2018. So far, he has 2 years industrial experience and 12 years teaching experience, in which he has handled most of our technical papers. He has published 4 national conference, 5 international conference paper, 6 national journal paper, and 15 international journal papers. He acted as research person for many hands-on training in the area of his interest, design experts. Many taught MATLAB and many other optimization tools. So far, he is acting as a reviewer for 5 international journals and act as an editor in the International Journal of Material Science India Publications from 2018. He designed a syllabus for value-added courses of and developed online content for finite element analysis also. With this short introduction, I welcome Dr. M. Varadarajulu for this national webinar, and now I hand over section to our resource person without any further delay. Thank you.
Thank you, sir. Thank you for the detailed introduction, sir. Good morning to one and all. Hope everyone is safe and healthy staying indoors during these strange days. I am very glad to associate with King's College. Since 2008, I am associating more than a decade. Considering the today's topic, application of design expert software in manufacturing industry. During COVID-19 crisis, we are unable to continue our research. So this webinar will assist you to continue the research. There are various stages in the research. This webinar aims to fulfill the needs of the beginner, and those who are having some data related to research. Perhaps many of us having data and expecting to continue the research, we are trying to publish the paper, but due to the incompletion, we are unable to do so. We can divide this webinar into 3 parts. One is introduction, that is nomenclature related to design expert. The second one is software execution and obtaining the various inferences from the design expert software. The third one is questionnaire. We will start with various terminologies related to design expert. Design expert is a package which assists us to plan or design our experiment. We need to start our study with our experimental investigation. Later, we have to do curve fitting or regression analysis. Curve fitting widely used for prediction or forecasting. Why we need prediction? Why prediction is needed? If you are able to do prediction, then we can act accordingly. Based on the prediction, we can act accordingly. In many cases, we are predicting or we are forecasting. Forecasting is the demand of the product or the profit. Forecasting of monsoon. Forecasting of rainfall. Forecasting of market strategy. Forecasting of atmospheric signs. In such a way, in many places we are doing prediction. Based on the prediction results, we can act accordingly. when a statistic comes into picture, there are many terms or unambiguous. Ambiguous. It is a 40-hour course, hence it is in 2 hours or 1.5 hours. It is not enough to reveal all the technical terms, terminologies, or nomenclatures. But I assure you, after completion of many terms, here many terms become unambiguous or clear. You can able to process your data with a design expert. Considering one particular journal, considering this journal, Journal of Material Processing Technology, here in the second page itself, the editor given that statistic method or technique from artificial intelligence which treat the process as a black box. This journal has around 4.6 impact factor, and which is indexed in SCA. And Journal of Material Processing Technology, in the second page itself, they are revealing that statistical method or techniques from artificial intelligence which treat the process as a black box. I assure you that once the webinar is over, we can conclude that it is not a black box, it is a white transparent box. The statistic method or a design expert is a white transparent box. We can process our data with a design expert software. Right. Considering statistics, getting the information from the data is nothing but statistics. And statistics are further subdivided into fine. And the science of collecting, describing, and interpreting data is nothing but statistics. And the collection, presentation, and description of sample data is said to be in descriptive statistics. And making decision over the conclusion drawn is nothing but inferential statistics. And when we are concerned about statistics, we need to know about population parameter statistics and the terminology related to statistics. Population is a group of all items of interest to a statistics practitioner. A sample is a set of data drawn from the population. And considering population is a set and sample is a subset of population. Parameter, population, a descriptive measure of population is said to be in parameter, and a descriptive measure of sample is nothing but statistics. And how we are getting the data from the population is very essential. Considering this example here, all the balls are having red color, then the sample ball should be in red. But considering this example, here there are three different colors of parameters are associated. While taking the sample from the parameter, we need to select the appropriate boundaries. We need to cover all the boundaries of the parameter. Then only the sample will predict accordingly. The prediction level of statistics will be more. Therefore, the selection of appropriate data from the parameters is very essential. And from the sample that we are going to infer the data. And population collection or a set is said to be in population, and subset of population is said to be in sample. And there are various terminologies related to statistics. From the example, we will read it. A college dean is interested in learning about the average age of the faculty. Identify the basic terms in the situation. A population is the age of all the faculty members is in the college. And among consider there are 100 faculties in the college, and among 100, 10 we are going for a sample, then that is said to be for the subset we are taking 10, that is said to be a sample. And a variable is the age of each faculty member. Data would be the age of specific faculty member. And in plural, the data would be the set of values in the sample. The experiment, the, how we are getting the information that is age from the faculty members is said to be an experiment. During entry itself, we are getting the data, or some other in questionnaire, or the form is given for circulation and getting the data. That is said to be an experiment. How we are getting the data is experiment. The parameter is interest in the average age of all the faculty at the college. Here, college dean is interested in learning about the average age. Therefore, that is said to be in parameter. In statistics, the average age for the all faculty in the sample. With this, we can enter into regression analysis. There are in regression analysis there are two different types of applications or encountered. One is trend analysis, and the another one is hypothesis testing. The first one is predicting the value of the determined variable may include extrapolation beyond the data points or interpolation between the data points. Either we are going to do extrapolation or we are going to do with interpolation. The hypothesis is comparing the existing mathematical model with the measured data. As I have communicated with the coordinator, it would be a hands-on training session. I will do the experiment with Excel. If it is feasible for you to continue, you can also do. Therefore, that's why I have given the various documents to the coordinator. I think so. Coordinator might circulated all those data with you. With the problem one, I have made this sheet empty in the second page. What we can do with the example will reveal this page. What we can do, assume there are five different experiments conducted, and the input for the experiment is X, and the input for the experiment is output for the experiment is Y. Considering input and output, there is in clarity is essential. Uh, what are the different names of inputs are independent parameter or parameter. Input set to be an independent parameter or parameter. Output usually set to be an output or a response or a dependent. There are various nomenclatures or the statistics associated with input and output. Input, independent parameter, input, and dependent parameter. And considering output parameter, output, responses, and dependent parameter. As we are concerned about linear mathematical model, what we have to do, we have to select the various input and the output, and try to get the scatter diagram. And this was the scatter diagram. From the format, we can get format selection. Here we have layouts. Still, we need to get the data from. trend. Here in layout we have trend, no trend line. Here display equations on chart and display R squared value on chart. Close. Here we have a mathematical model. This is usually said to be an empirical model, and the bottom one is reliability measure. That is R square value that we will discuss in detail later on. Based on this equation, what we can do, we can predict the y value. This is y, the prediction of y. How we can predict? I am giving the equation equal to 5.4 into x. Here, x is assigned in b and plus 9.2. The actual y value is 10, the predicted y is 9.2. I am going to drag down. I can able to predict the data. I am doing copy and paste here. What was the reliability measure? How we can select whether the model is, how we can come to a conclusion that the model is suitable for us. How we can represent the model is further, it is without any doubt we can use the model. There are two different methodologies available to confirm the reliability. One is R. The R square value should be nearer to 1. The another one is average percentage of deviation. Based on these two, we can suggest one particular model for the further usage. And how we can get the percentage of deviation? Here, the percentage of deviation can be calculated with actual minus predicted divided by actual. Here I am doing equal to actual y minus predicted y divided by actual into 100. This is the formula for getting the percentage of deviation. If the percentage of deviation is 8, and drag down. Here, if the percentage of deviation is in the positive and negative, it won't give the reliable average percentage of deviation. Therefore, it should be an absolute value. Then what is the formula to get the absolute percentage of deviation? Is here use ABS. ABS returns the absolute value. If your value is 8, then it will return 8. If your value is minus 4, then also it will returns the 4 alone. It won't give the negative value. And here, give the average value. The regression coefficient is here. The regression coefficient is 0.991. I am changing the numerical values. Here, get the data from the chart, that is 0.991. Similarly, you can do a linear, or what are the options are available with the default Excel is. We have linear, exponential, and linear forecasting. There are various linear, logarithmic, exponential, polynomial. In polynomial, what till sixth order we can do the empirical model, and power and moving average. The things which is required is there are two possibilities of getting the inference. One is R square value, the another one is average percentage of deviation. Here, I did linear relation, quadratic, and cubic, and exponential, considering the average percentage of deviation for linear 4.1 and 0.992, here 2.27 and 0.995, 1.2261 and 0.998, here 3.8 and 0.989. On various empirical models, which one is preferable? The superior regression coefficient is preferable. Here, the superior regression coefficient is the quadratic equation has the superior regression coefficient, that is 0.995. Similarly, it has least percentage of deviation. Here 1, here 1. No, cubic has the superior R square value, and the respective average percentage of deviation is low when compared with the other empirical model. Therefore, in particular to this case, cubic equation is suggested. Then, what are the difference between this Excel and the design Excel? With one input and one output, we can do analysis with the Excel. If more than one input and more than one output, we cannot do analysis with the Excel. Yes, we can do, of course, but the add-on package is essential. Again, there is a problem with the reliability of such add-on. Therefore, design expert software is suggested for doing the empirical model, which has more than one input and which has more than one output. And as I said earlier, there are various terminologies need to be need clarification. Here, I have given a detailed scientific pages, which one it is audible. Someone answer, it is audible. Okay, shall we continue? Yes, I have given the mathematical calculation. If one wish to do the mathematical calculation manually, these pages will assist you to do the mathematical calculation. Whether it may be a linear mathematical model, or whether it may be a quadratic. The linear mathematical model is you can get the data, various information related to linear mathematical model from page number 1 and 2. The quadratic example 2 reveals the information about the quadratic mathematical model. And the other terminology is related to mean, standard deviation, variation, coefficient of variation, standard error of estimate, and standard deviation. These things we need to know before we are going to write an article. But here we will see the inferences, how we can get the data from the software. Therefore, I am giving the opportunity to learn the various terminology related to mean, standard deviation, variation to the audience. And considering R is a very important measure. Carl Pearson coefficient of correlation. Who is the who is the father of modern statistics is nothing but Carl Pearson. He introduced the term called the coefficient of correlation, that is R. The product moment of correlation or coefficient is said to be R, and the square is said to be a coefficient of determination. This we are taking as a measure of reliability. If it is the R square value is nearer to 1, then the model is reliable. If it is not closer to 1, then the reliability is a very big question. And apart from there are the different ways to get the R square is we have given here. There are 3 different methods are available. The other one is adjusted R square, and 2 different techniques are available to get the data for adjusted R square and predictive R square and adequate precision. You can get the information. The software gives these data. What are the data? I have already executed the software. We will open that software. I have given for the audience also. If you have the software, And if you have the document, then open it will be useful for you to get the inferences. One factor. I have circulated various PDF and four documents, around 8 PDF and four design expert software and 5 images and one Excel and one notebook. These are the data I have circulated to you. The same thing which we did it in Excel. What all the information we can get through the design expertise analysis, R1, model, and ANOVA. These are the data which I have given in detail. How one can get the data from the how one can get the data manually. That is, as I said earlier, it is not a black box. We can do manually. It is not a black box. We can get the data. We can do each and every one manually. That I have given in detail in this video. 8.9, 24.77, and 9.98, and the R square, adjusted R square, predictive R square, and adequate equation. Similarly, for the linear mathematical model, it is okay. How one can get the how one can do the ANOVA and how one can do the mathematical model for the responses which has more than one. For that example, also I have given a detailed study. ANOVA. This ANOVA you can do the various calculation, assist us to get the ANOVA is given here. ANOVA square, mean square, and depth test. The various tables, statistical tables is essential. The tables also I have given. The mathematical model derived through the manual calculation is here. This is the mathematical model. A true life, what was the data here? What was the data? A true life, for a true life, there are three different replications are available. Replication means here, true life 1, 2, 3. The experimented repeated 3 times. The input parameter, they doesn't bother about the input parameter, they are giving only the responses. That is 2 like 1, 2 like 2, and 2 like 3. We are going to do the mathematical model for this 2 like. How we can do the mathematical model? From basic calculation. ANOVA. Then, based on ANOVA, we can get the various terminology related to the mathematical. And this is which I have given in detail in the manual calculation. And in view of the design expert software, for the beginner, we will assess the beginner and those who are having the some data, we can do the mathematical model and we can get the various inferences from the design expert software. For that, I have chosen one particular paper, and in that paper, they have revealed a detailed study, and they have given detailed information about the ANOVA and given the various inferences about the input and output. And article is the evaluation of surface roughness parameters in drilling of amorphic composite panel using box bending experimental design. Once we will enter into some slides and later we will have the hands-on with the design expert software. What are the parameters? Other parameters are available with the PPTs and the curve fitting. There are which I request the audience to have a visit over the PDF, that is manual calculation and arithmetic mean and standard deviation, variation, coefficient of variation. How we can do the mathematical model or empirical model. Goodness of fit. This is very important. This is correlation coefficient. The same thing for the polynomial regression for higher order. Second order polynomial. How we can do the second order polynomial? This is the ANOVA for the single factor fixed defect model. These things I have given in detail in the annual calculation theory. Least square set of sideline example. Okay, which we have come across in the Excel. Variation and the other terminals related to the mathematical model, variation, covariation, and polynomial regression. Here, R square is a measure of amount of variation around the mean by the model, and the adjusted R square is a measure of amount of variation above the mean explained by the model, adjusted for the number of terms in the model related to the number of points in the design. Therefore, there are three different R square, adjusted R square, predicted R square. Each R square should be closer with each other. It should not be deviate 0. The maximum deviation of this three is 0.2. The adequate equation should be it should be greater than 4. The first value. I have given how one can calculate the various terminologies in page number 1. Here factorial, polynomial, factorial. Here we can find the various terminologies. Sum, mean, correlation coefficient, standard deviation, variance, coefficient of variance, and the first value. Predicted error sum of square is said to be in plus and ANOVA. And the example which we have seen for before life, that is also given in Excel. The empty sheet is given for you to practice. And correlation coefficient, calculation of correlation coefficient, and adjusted R square, and the predicted R square, and ANOVA. This we have seen in the design expert chapter itself. Design expert, and what we can do with the design expert, planned activity whose results yield a set of data is experiment. It is an design expert is a statistical approach to plan our experiments. It is a systematic technique for planning, designing, and analyzing. A methodology to achieve predictive knowledge of complex and multivariable process with the fierce style possible is nothing but design expert. And the terminology related to DOE, so response, measured output is said to be in response. Factor, input variable is nothing but factor. As I have already given that output, it has various names: response, depending parameter, dependent, and response. And considering input, factor, independent, and variable. Treatment, different combination of the condition that one wish to test is nothing but treatment. Level, specific values or factors is nothing but level. We need to have clarity over the level that I will reveal. Replications, for the same experiment, how many times we are repeating, that is nothing but replications. And the goal of GUI, identify the individual effect of each input variable, determine combined effect, interaction, that is interaction effect, and determine the experimental error, obtain maximum information, obtain the maximum information from minimum number of experiments run. This I will give a detailed history for this goal of DOE. And what are the other boundaries of DOEs? Major approaches of DOE is factorial design and response surface design. Under response surface, we have central composite, box thinking, one factor, and so on. And factorial, we have two-level factorial, general factorial, and Tabuchi. And combined design or mixture design, combined as de-optimal and user-defined. We can also have our own method of doing modeling with the help of this tab. Mixture design, simple lattice, simple centroid, screening, de-optimal, distance-based, user-defined, historic data. And factorial, considering factorial, all combination of the factors are tested in each replicates is assisted with the help of factorial. And we have only fewer combination, then fractional factorial are enough to do the modeling with fractional factorial. And what are the things, what are the procedure of DOE? Calculate the sum of square and determine the degrees of freedom, calculate mean square and F statistics and physical FIV and compare with the confidence line with the table. This we can get the inference, with this we can get the data from the manual calculation. And factorial design, if there are three different factors are considered, assume A, B, C, which has two levels. So consider it is -1 and 1. The design is called 2 for 3 factorial, and 8 treatment combinations we have to do, and based on that 8 treatments we can do our empirical model. Generally, the experiments can be designed based on some level per factor. If our level is 3 and the factor is 3, what is level and what is factor? We have spindle speed, feed rate, and depth of depth. That is said to be a factor. And in each factor we have 3 depth levels. In speed itself we have 100, 1000, 3000, 5000. That is variation. That is variation in each factor said to be in level. Similarly, the other level is also has three levels means the basic experimental size should be 27. This is the experiment which I have given in the PDF, and cutting speed, tool geometry, cutting angle, and these are the two life, and how we can do a mathematical study. But these things we can get from the PDF, manual calculation. NOVA, based on NOVA, we can do the regression model. We can get the regression. What we can do, we can have a test run over the design expert software. We will get the inferences. Then we'll go to how one can get the this is for design. This is for linear model, which I have already feeded. Assume this data. What was the data? The authors concerned with the box thinking design. I will later I will inform that what was the advantage of box thinking design, how it is superior than the central composite and other design, and the input essential for entry in the software is these data. For the beginner and introducing the software, go to start and design expert, new surface roughness and box thinking. Here the number of factors defaulted lower number of factors is 3, schedule 3. Here, note it down. What is the input parameter? A, speed, and diameter. I'm giving the input speed. The unit for A, for the speed is mm per minute. Don't enter the units in the unit track. Here it will give the units. It is a text, it does not have any influence over the responses. Speed. Hundred prime minus 0 and plus minus 0 and plus 500 and 500. Here 1000 and 5000. 1000 and 5000. 4 and 2. 4 and 4. P. Box Venkin has the replication, 5 replications in its center point. See the diagram. These are the boundaries of box Venkin design. It is the center point. This is the center point of this axis. This is the center point of this axis, and this is the center point of the entire box. It has 5 replications. The replications have the control over the other controllable factors. Here we are considered only 3 input parameters: speed, speed rate, and diameter. Even many other parameters may also affect our responses. Here the considered responses are RA and RZ. RA, average surface roughness, and peak surface roughness considered as responses. Even many other responses like floor vibration, tool vibration, arbor vibration. There are a number of parameters may affect the which is not considered in the study. Even may have the control over the responses that has to be addressed via this center point, this replications which can be addressed. The center point, 5 points, that is replication in 0th level, has the control over the uncontrollable factors, which have very good control over the other inputs which we didn't consider in the study. Therefore, it is superior than the other model. Here, the response considered are RA, Q2, here. R is here we need to give the R and R is the value. Before that, we need to do charting. I have already have the design experts out there. Charting, I will introduce how to do charting. Here, charting in Excel, that is different. Here, charting can be done. See, here do short by this factor, short by this factor, short by this factor, short by this factor, and short by this factor. This will assist in beginning do shorting. Similarly, do backside shorting. It will give you the shorted data. Similarly, in this, which I have already given, I'm giving short by this factor, short by this factor, short by this factor, short by this factor, short by this. What I'm doing is I'm doing in a designing way. I'm ordering the input parameters for doing copy paste or in the way which given in the let's see 100, 500, 100, 500, 1000, 1000, 100, 100, 100. In a different way, the authors reveal, and we did the charting. And we're doing copy here and pasting. For a beginner, you have the data, you give the data one by one with the available information. Don't do charting. Over a period, you do charting. Right, that's all. What we can infer from this design expert, we can do various information. We can get the various information based on this design expert. Here, summary. So what we did, we can view in this tab. There are 17 observations. We are going to do with a nonlinear mathematical model, that is polynomial, the minimum in array and the minimum in RZ. We have worked in analysis part. We have worked in analysis part. Sabha sir, it is audible. Sure. And go to analysis part. Go to analysis part and give array. Here, fit summary, model. Don't do anything. Don't do anything. Simply click over the tab. Don't do anything. ANOVA. This is the ANOVA which we have derived from the software, which is similarly given in the article. See the article. See the article for array. See the data 30.13, 30.07, 3.15, and the respective data are in Summa square. Summa square, degrees of freedom, mean square, and F value. What was the inference from this table is the inference are given at the bottom of the software itself. What we have to do? We have to do rephrasing. Rephrasing is enough for carrying out the ANOVA. We need to get the data. These are the lines which give the inference for this array. RZ for RZ, we can get the RZ ANOVA from this tab. And what was inference? And among the input parameters considered, that is A, B, C, which is significant input parameter, whether A or B or C. Here, which has lesser than 0.05 has the significant terms. Here, A, B, C, AB, A square, B square, C square are the significant model terms. If one wishes to identify the appropriate input parameters, say for example in solar there are n number of input parameters are to be considered. One wishes to reduce the number of input parameters. Then it is suggested to do the experiment with ANOVA. Further ANOVA will suggest what was the most reliable or most influencing input parameter. Based on this study, we can limit our input parameter. Then we can repeat our experiment for further clarification. And this is one point. The second point, we can get the order of importance. You may already arrived about the Taguchi technique. What Taguchi will do the ranking. There are three input parameters considered. Among three, which has most influencing? Rank 1 has most influencing process parameter. Rank 2, next to the rank 1, rank 2 will influence. The rank 3 is the least importance. That is also we can get from this value, this F value. Among the three, that is F value, among the three, which has largest absolute, A is the largest absolute, B is in next to that of A, C is next to that of B. Therefore, among three, the order of importance is A, B, C. That is, A is rank 1, in Taguchi, A is rank 1, B is rank 2, and C is rank 3. Similarly, we can get the inference for RZ also. Then, see the picture. What we can do, identify the individual effect of each input parameter, determine the combined effect. That is what we are going to do with the graph. This is the error analysis. If your data is scattered through the line, then your experiment has very good control over the mathematical model. Your experiment, there is no need to repeat the experiment. The experiment has a very good hold. Then model graph. How we can get the model graph? Okay, model graph and the view and 3D surface. From this graph, we can do various inferences. I'll give the various inferences one by one. Spindle speed, shear feed rate. We can also try with this. We can get the inferences from this point. Considering this spindle speed, the increase in spindle speed, this is the inference. This is the inference. What I am telling is, what I am communicating is the inference. Inference from the graph. That is essential for the article, or it may be for the thesis. It is very hard to get inference from other softwares. The design expert gives reliable inferences based on the curve fitted by the input and responses, input and output. The increase in spindle speed doesn't have much influence over the RE. That is point number one. The point number two, the increase in feed rate. Increase in feed rate increases RE. Point number two. Point number three, what was the least point of RA? At the lower feed rate, the third point is the lower feed rate with 2000 RPM speed will produce minimum RA value. Here, we can rotate the chart. We can get the default. And what was the last point? The fourth point is the combination of lower speed and higher feed rate. Higher feed rate will produce the higher RA value. Like that, we can do inferences. What we did, we are doing forecasting. This is the way for the other experiment, the RA will respond. Based on this, we can have a control over the RA. If audio, it is audible. Oh. We'll pick the audio. Now check. Yes. Now it is okay. Now it is. As a researcher, we need to do the RA should be minimum. The RA, that is the average surface roughness should be minimum. If we are having the input as 1000 and 500, then it won't be minimum. It might be very huge. Therefore, in order to have a control with the minimum, in order to have the minimum RA, it is suggested to have the feed with 100 and speed with 2000. This is what we are inferring from this three-dimensional graph. Similarly, we can get the one factor graph. This is what we are getting from the one factor, which is available in one factor. The increase in feed rate increases the RA for A, and increasing spindle speed decreases the RA. And C, increasing drill diameter increases RA. We have A and B. The three-dimensional graph is we seen A and B. Similarly, we have to do the analysis with AC and DC. Considering AC, what was the inference? The increasing feed rate increases RA. Point number one. Increase in drill diameter increases RA. The third point, the combination of lower drill diameter and lower feed rate will produce minimum RA. the combination of higher drill diameter and a higher feed rate will produce higher RA. Similarly, for BC, what was the inference? Here, what was the inference? Increase in drill diameter increases RA. Similarly, increase in spindle speed also increases RA. The combination of lower drill diameter and higher spindle speed produces smaller RA, and the combination of higher drill diameter and lower speed rate will produce higher RA. This is the inference we can get from the three-dimensional graph. Similarly, the contents may be cross-checked and verified with one factor and interaction graph. This is what which I have given in PPT. Identify the individual effect, that is individual effect of each parameter, that is the speed effect over the speed, effect of feed, and the effect of drill diameter. Determine the combined effect, that is interaction effect, A and B, A and C, and B and C. Determine the experimental error. Experimental error can be derived from obtained from this page. If the data are scattered, all the data are scattered like this, then we need to do the experiment again. It should be scattered along the line. Then the experimental procedure can be extended for doing mathematical model and even for optimization. And the last one is obtain maximum information from minimum number of experimental trials. And similarly, we can do the analysis with RZ. RZ simply I'm taking over the tab, model and ANOVA and diagnostics. TSC, it is scattered at one particular point. This won't be model graph. ANOVA, this is the ANOVA, whether this is the ANOVA is given, we will check. 9,047, 9,047. The same ANOVA we are getting. These are the graphs which we can get from the design expert software. This author given gray color graph rather than the color graph. The author given gray color. What we can do further? We can do this mathematical model. Where we can get the mathematical model? This is the mathematical model. This is the mathematical model. Based on this mathematical model, we can predict RZ. Based on this mathematical model, we can predict RZ. If we have certain data, based on that data, we are given as an input for design expert. The design expert can give the mathematical model. Further experimental is not necessary for same constraints. That is very important. For the same constraint, there is no need to do the experiment again and again. With this mathematical model, we can start our iterate. We can get the data from this design expert software. Further, what we can do optimization with design expert software. What is optimization? There are plenty of information available with optimization. Here, we will narrow down our webinar. Here, the default optimization tool is available. The default optimization tool is desirability function approach. This approach is said to be a desirability function approach. What is our need? Our need is to reduce RA. RA should be minimum. RA should be minimum. The R also should be minimum. Not to get the quality component, both should be minimum. The solution. This is the input suggested for getting. This is the optimized input parameter. That is 100.49, 3085, 85.46, 4.01, and RA. That is RA and RZ. And again, there is a problem with the data. I mean, Here we can give the 100.48 as an input parameter. In CNC, for conventional, it is not feasible. And for build diameter, it is 4.01, and we cannot give accurate build diameter for the experiment. This is the optimized input parameter. This optimized input tab is said to be desirability function approach. We can view this diagram in some of the paper. This is the input parameters, and the how the reliability measure in the um, earlier study is R square. Here the reliability measure is desirability. If the desirability is 1, then that is the model is good. Otherwise, we need to iterate with our experiment, or we have done some changes with the experiment. We can use this graph in our either for a journal, for preparing the manuscript, or in the thesis. In the report, gram graph, and bar graph. The graph, this is the optimized graph. And this is what I have given in obtaining maximum information from the minimum number of experiment trial is this is what we did. We are having some data with the experiment. We are going to give the input in design expert. Design expert will do the ANOVA and empirical model. The empirical model we can suggest for further studies. Similarly, it can be extended for optimization. In one particular paper, I have given, but is also circulated. In this paper, I have carried out box printing design and genetic algorithm. Here the various terminologies, standard deviation, R square, adjusted R square, and sum of square, and adequate quotient. And ANOVA has one particular response, and the mathematical model, and graph, three-dimensional graph. With this three-dimensional graph, we can do our inferences. The desirability function approach can be that I have not circulated. This is the paper, transactional induced metal. The desirability function approach is applied to do the optimization of active digital aligning of AL70 with nickel program. At the end, you can view the diagrams which we have seen in the software. Another one, statistical data, and the normal plot, and the three-dimensional graph, and the mathematical model, the normal plot, three-dimensional graph, this is the desirability function approach graph, which we can derive at the end of the design execution. And that's all about my presentation. And if you have any query, you can ask one by one. Subha, please. I hope Minitab is a very good parallel software which is used to do the analysis. Minitab. If it is no other queries, my sincere acknowledgements to the coordinator and head of the R&D and the HOD of King's College who given the chance to disseminate the information related to design expert. Thank you. Thank you, Vinod. Any other information? Sir? If there is no queries, if there is no queries, someone since I have I used to detail about two different points. How the number of experiment is decided in box banking is 3 power k plus 1 n. I have expected since some participants may ask the number of experiment over the box banking design is derived from 3 power k plus n. 3 power k plus n. K n is the replication of center point, and the other one is simple composite design. The number of experiment in simple composite is decided based on 2 power k plus 2k plus n. 2 power k plus 2k plus n. Nothing else, Sabha. Nothing else. Appreciate you have taken very huge effort for conducting this webinar.